Hello everyone, my name is Mei. Today I will be presenting the stage 3 of my project, and this stage focuses on building a multiple linear regression model to explain and predict the final exam score of the high school student by using the multiple student characteristics. And the goal for this stage, we want building a multiple linear regression model, performing variable selection, checking model assumption, making inferences about predictors, and finally, make the prediction for a new student. So by the end, we want a final model that's trustful for both inferences and prediction. Based on the AIC forward selection and the figure that I provide on the screen, the highest adjusted R-squared is 0.19. Our current model contains about 6 to 7 predictors, and I select a model that contains a student study hour, GPA, assignments, attendance, screen time, the school type, and finally the tutoring. Those variables that were consistently present in the top performing models. The first model I built contained all the predictors that I select from the last page, and the diagnostic plot shows a clear violation for the assumption, and the residual plot shows a strong trend pattern indicating the non-linearity and the non-consistent variance. And as mentioned in the stage 2, there has a strong ceiling effect because so many students scored at 100 in the final exam, which compresses the residual and the thread model. The QQ plot shows a substantial deviation from the straight line in the left tail, indicating the residual are not normally distributed, again driven by the ceiling effect and uneven spread. Overall, those plots suggest this model are not a valid model in its current form, and a transformation should be considered. To improve the model to fit the assumptions, first I've tried the log version and square root version of the response, but sadly it's given the diagonal plots that really similar to the last page, which is they are not a valid model for the assumption. And then I applied Box-Clock method to search a powerful transformation of the final exam score to improve the linear model assumption. As shown as the result, it's indicated no power transformation provide a meaningful improvement in the model. So which means there's no optimal lambda that can correct the ceiling effect in the final exam score. Therefore, I did not adopt this transformation and continue with the original response with acknowledging the limitations. And then I'm trying to transform some predictors, such as log study +1 and log screen +1 to improve the line assumption, but this transformation do not show an improvement in the diagnostic plot because these transformations do not fully remove the ceiling effect driven skewness in the residual. Just like what I mentioned in the stage 2, there still have two structural issues that can explain why no transformation produce a valid model. The ceiling effect. So many students achieve a perfect score of 100, compressing the upper part of the scale. The linear regression assumption cannot hold when the response is capped. When also the missing predictor, I do think there still have another predictor that's not contained in this data set can explain the student's final exam. And then I tried to add an interaction term into this model to improve the model fit. First, I've tried the study and GPA interaction term, and it's to improve the model fit and increased adjusted R-square from 0.19 to 0.25, and this indicates that the benefit of the study time depends on the student's GPA. If the student have a lower GPA, and she or he will gain more from the additional study time than the student who already have a high GPA. So I trying to add this term into model. I also examined the school type, which originally contained public, private, and charter categories. And based on the output from the first model that I just built, the charter school indicator was not statistically significant, with a p-value of 0.426, and did not contribute to improve the model performance. Therefore, I simplified school type into just another versus private that keeps the model cleaner and easier to interpret. Based on all the things that I just mentioned previous, I create a new multiple linear regression model, and based on this model, I produce the diagnostic plot, and I still gain the similar plot that with the model that we previously used, which do not fully satisfy the line assumption due to the ceiling effect in the final exam score. So finally, I already tried all the methods that covered in the class to address this issue, but badly it's not work. And removing all the data points that with a final score of 100 would satisfy the line assumption, but this would cause a severe data loss. Therefore, this model is suitable for inferences and prediction. The ceiling effect remains a significant limitation in this model. Next, I test each predictor using the hypothesis test and the confidence interval. And the significantly positive predictor including student, study hour, GPA, assignments, private school, tutoring, and the interaction term. By checking all the p-value for each estimate coefficient, the tendency and the screen have the p-value that higher than 0.05. So both of them reject the non-hypothesis. And the confidence interval also proved this. Their CI including 0, so it suggests the relationship is not statistically significant after adjusting for all the other predictors. And finally, we're trying to make a prediction for a new student by using this model. And the new student information as shown on the slide. And we have the 95 confidence interval and 95% of prediction interval, which means we have 95% confidence that the average final exam score of all students with those same characteristics lying between 98.39 and 99.37 points. And for one individual student with those characteristics, we expect their actual score to fall between 94.02 and the 100 points with the 95% confidence. In conclusion, while none of the model that I create can fully meet the assumption, but the final model that I select can also to be used for the approximately predictions for the new student. My analysis highlights both the usefulness of the model and its limitation, especially the ceiling effect and the missing predictor in the dataset. Finally, thank you for listening.